This is recording 1D on our series on completing the square from Chapter 3 of Mathematics 2200. We'll focus on creating and using quadratic functions in problem-solving situations. This first example deals with revenue, so I'll call it the revenue problem. Adine is considering pricing for the mukluk she sells, and last year she sold them for $400 a pair, and she sold 14 pairs at that price. She predicts that if she increases the price by $40, she'll sell one fewer pair. Every time she increases by $40, that's what happens. Determine the selling price that gives the maximum revenue. And revenue, by the way, is the number of items sold times the cost or price per item. Set up a table here to help us understand the problem. Let's say I had one price increase of $40. That means Adine would sell for one price increase, she would sell one fewer pair. So it'd be 14 minus 1 times 1, or 13 pairs she would have, or that she would sell. If it was two price increases, it would be 14 minus 2 times 1 would be the number of mukluks sold. And for 3 price increases, 14 minus 3 times 1. For 4 price increases, 14 minus 4 times 1. Therefore, if it was X price increases, it would be 14 minus X times 1, which we would typically write as just 14 minus X. Let's work on an expression now for the new price. Originally, she sold them for $400. If she had one price increase, that would be by an amount of $40. Two price increases of $40 would give a total of $480. If there were three price increases, they'd be $40 each, added on to the $400, and 4 price increases of $40 each would get added onto the $400. So if there were X price increases of $40 each, we'd have 400 plus X times 40, which would be 400 plus 40X is the way we would typically write that. Now, to get expression for revenue, we take the number sold times the cost or price. So in the first case, I would have 14 minus 1 times 1 times 400 plus 1 times 40, the amounts in the two columns. So continuing on down, I do the same thing. I multiply the expression in column 2 by the expression in column 3. That gives me an expression for the expected revenue until I get down to the expression that involves X. And I'll bring that over to a new slide. Therefore, my revenue, R of X, is equal to 14 minus X times 400 plus 40X. I need to expand that, and because I'm trying to maximize the revenue, that tells me I need the vertex for the parabola. Because this parabola is in standard form, I'll use negative b over 2a rather than completing the square. So negative 160 over 2 times negative 40 gives us 2. So I substitute that 2 into my revenue function, and I get $5,760 is the maximum revenue. But that wasn't all we were asked to find. All right, this is the vertex. So the maximum revenue is right there. The X value that gives it to us is right there. But that's not the new price. Remember, X represents the number of price increases. So we have 2 price increases. In this problem, they're worth $40 each. So our new price is going to be $480. Here's a summary of the steps used. Choose a variable to represent the number of price increases. Write an expression in terms of the variable for the number of items sold. Expression for in terms of the variable for the price per item. And use the relationship revenue equals number of items sold times the price per item to form a quadratic function. Quickly before we do example 2, rectangles rather with the same perimeter can have different areas enclosed. For example, I've got 3 rectangles, all of perimeter 12 units. Out of the sides you get 12 units. But the area is different for each one. 5 times 1 only gives us 5 square units here. 4 times 2 is 8. 3 times 3 is 9. I've done 3 rectangles. The directions here say 5. You do the other 2. We need to think about that idea as we're solving a problem like this involving area. 160 meters of rope is available to create the perimeter of a rectangular play area. One side of the rectangle would be against the house. Determine the dimensions of the rectangle that can be formed if the area to be enclosed is maximized. Step 1, sketch a diagram. So my play area is adjacent to a house. Decide which sides will actually use rope. Well, that would be this side, and this side. We don't need to include this side here because the house is forming one side. Step 3, write an expression relating the sides using rope to the amount of rope available and solve it for a variable. So my length plus my 2 widths are equal to the amount of rope available. I solved that for a variable, usually the easier one. I'll choose L in this case, like so. I write the formula for the area of a rectangle as length times width. And I can use the expression I found in the previous step to replace L in this formula. That results in this function, which I can expand by distributing the W through the terms, which gives me this expression. Step 5 says expand and interpret the vertex. So like the last problem, I use negative b over 2a to get 40 for the x-coordinate of my vertex. That'll give me a maximum area of 3,200 when I put the 40 in here. My vertex is 40 and 3,200. So the width that gives the maximum area is 40 meters, and the maximum area is 3,200 square meters. But the other dimension we still need is length. We knew it's negative 2w plus 160, which gives us 80 meters. To summarize this clip, maximum revenue problems follow this series of steps. Max min area problems, you can use this set of steps.